Hey, good morning, everybody. Here are some more examples of proofs for proving identities to be true. These are from section 3.2, numbers 38, 40, 42, 44, 46, 54, and 56. And these are pre-worked out solutions, so we'll just go ahead and take a look at them and make a few notes as we go through them. So here's the first one, number 38. The given information, we started here. For this one, what you would want to do first is take tangent squared and change it to sine over cosine, so sine squared over cosine squared. And here you can see that your cosine squareds will cancel, and you're going to be left with the left side now shown to be identical to the right side, so sine squared is equal to sine squared, and that should be your proof for that one. For number 40, the first thing we would want to do is switch cosecant to 1 over sine. And here, one factor of sine is going to cancel with one of the three factors of sine up top. So you have sine cubed. So that's going to be sine, sine, and sine. So one factor of sine will cancel one factor of sine up top, and that's going to become a sine squared. And that will lead you to having 1 minus sine squared. And 1 minus sine squared from our Pythagorean identities is identical to cosine squared. So that will get us cosine squared is equal to cosine squared. And the next one, number 42. Cosecant squared can be changed to 1 over sine squared. And that is going to now get us a cosine squared over sine squared, which is cotangent squared. And from our Pythagorean identities, 1 plus cotangent squared is identical to cosecant squared. So that should be number 42. Number 44, the first thing you would want to do is factor off a common factor of cosine. So you have one factor of cosine here. You have three factors of cosine here. So you want to factor off that common cosine. And what's left behind is sine squared plus cosine squared. I did see quite a few students when they were doing their work. They didn't have the parentheses here. You need to have parentheses because it's now cosine multiplied by sine squared plus cosine squared. So you do need those parentheses there. And once you have the cosine factored off, we know that sine squared plus cosine squared is just equal to 1. So we end up with 1 times cosine. And then you still have it over sine. So you basically end up with cosine over sine. And cosine over sine is cotangent. So that would be your proof for that one. Number 46. And the first thing you could do is switch cosecant to 1 over sine. It's reciprocal. And switch your secant to 1 over cosine. And then you're going to have a sine down bottom that will cancel one of the factors of sine cubed up top, so you're going to be left with sine squared up top. And then a factor of cosine will cancel with one of the factors of cosine up top, so you're going to be left with cosine squared. And sine squared plus cosine squared should be equal to 1. So we will get the left side to equal the right side, and it will say 1 is equal to 1. And that is number 46. Number 54. One thing you could do to start is to get common denominators. So we need to have a denominator that has a factor of cotangent in it. We also need to have a factor of cosecant. That's going to be our common denominator. And what did we do to the first fraction? We had a cotangent already, so we multiplied in a new factor of cosecant down bottom. So you need to, basically what you're doing is multiplying both the top and the bottom by cosecant to get that common denominator. So we wanted to do cosecant down bottom and cosecant up top. That's going to get us cosecant times cosecant, which is cosecant squared, and it's going to create that common denominator, cosecant times cotangent. And the second fraction, we needed to multiply in a new factor of cotangent, since we didn't have cotangent in the original denominator. So you're going to multiply cotangent into the top and also into the bottom. So that's going to get you cotangent squared up top and cotangent cosecant down bottom. Once we have our common denominator, so we have a common denominator of cotangent cosecant, we can now put that all over our common denominator. Cosecant squared minus cotangent squared, which is what we have here. From our Pythagorean identities, that is going to be a value of 1. So you have 1 over, and then down bottom we can take our cotangent and change that to 1 over tangent, which gets us a situation where you can just, if you're dividing by 1 over tangent, you can multiply by the reciprocal, so that's going to bring your tangent and bring it up into the numerator. So that's going to get your left side looking like your right side, so tangent of x over cosecant x. And that should be your proof for number 54. And number 56. First thing you could do on this is recognize that that is a difference of two perfect squares, so you can factor that out to be a 1 plus sign, a 1 minus sign, and now you have common factors top and bottom, and you can cancel your common factors, which would get us 1 plus sign all over 1, and if we need the left side to look like the right side, we can multiply cosecant into both the top and the bottom, because we definitely need a cosecant in the bottom. So if we multiply the bottom by cosecant, do the same thing to the top to keep it balanced. And when you distribute your cosecant into the numerator, cosecant times 1 should get you cosecant. And cosecant times sine, cosecant's the reciprocal of sine, so that's 1 over sine, so that is going to get you the 1 that you need, and then cosecant times 1 will get you the cosecant that you need. So now your left side will turn to this, and it will stay equal to the right side, and that should be your proof for that one. And those are your examples for those problems.